Chapter 16, question 141. It is a question about a compound with the formula C5H11Cl. Now, this C5H11Cl exists as a mixture of two optical isomers. This means this compound has a chiral center. Then when heated with sodium hydroxide in ethanol, okay, this is an elimination reaction of halogenal alkane. So a mixture of only two alkenes is formed. We get only two alkenes. You don't get more than two alkenes. So what could be the colorless liquid? Okay. Now this type of question, do not try to work out the structure only based on the molecular formula. It is easier to work backward as you look at the answer and see and start working backward and see whether you can get only two alkenes or not. Now, first of all, we find whether uh, any of them does not have a chiral center. A, B, C, and D. Okay, if there is a chiral center, okay, I'll just put a red dot on the chiral carbon. Now, this C is bonded to HCl, and then it is bonded to two ethyl group. So there is no chiral center. A cannot be the answer. Now let's look at B. Okay, this C is not the chiral center. This C bonded to 2H, not the chiral center. Not the chiral center. This C is bonded to propyl group, 1H, 1Cl, and then 1CH3. Yes, there is a chiral center. Now let's look at C. This one not chiral centers. This C bonded to 2CH3, not chiral center. This C bonded to this whole group, bonded to H, bonded to Cl, bonded to CH3. Yes, there is a chiral center for in C molecule also. D, okay, this carbon is bonded to ethyl group, bonded to Cl, bonded to 2CH3 group. Okay, no chiral center. D cannot be the answer. Now, so from the first property they told us that it has a chiral center, help us to rule out two answers. So we only need to look at B and C. So B and C, which one, when undergo elimination, will give only two alkenes? Now this question asks us to consider structural isomerism and also stereoisomerism. So if you get two alkenes, but one of the alkenes has cis-trans isomers, that would be considered as three alkenes. Okay, that is what it meant by we should also consider stereoisomerism. Okay, now let's together start working from B. Okay, B. Now B, I'll draw the structure of the halogenal alkane. Okay. Alright, now I start drawing the hydrogen. CH2. Then the next C bonded to H bonded to Cl. Okay, elimination means you will remove a HCl molecule from this halogenal alkane. So what do? Is we will remove this Cl, and then we remove one H, okay, from the neighbor carbon. Now this carbon bonded to C has two adjacent carbon, this one and also this. Now both adjacent carbons also have hydrogen bonded to them. So this elimination, you will get more than one alkene as the product. I'll start, I'll start with removing H from the left hand side adjacent carbon. So here I have CH3, okay, CH2. Now this, remove this, there's a double bond between these two carbon. Okay, this is still bonded to H, it's bonded to CH3. Okay, now this carbon is bonded to H. Look at this product. Okay, every carbon sharing the double bond one, this carbon and this carbon, they are bonded to two different groups of atoms. So they will be cis and trans isomer. Okay, cis isomer consider one alkene, trans isomer consider the second alkene, because the question asks us to consider stereoisomerism also. Alright, now I would like to okay, look at the second type of alkenes. Second type of alkenes that can be produced from the elimination of this halogen alkane. Now I will use the green color one to circle the atoms that I will remove. So here I'll remove one of the hydrogen. Okay, let me erase this. I'll probably show you the whole structure by using display formula. Okay, I'll remove this hydrogen. Now, this will give me CH3, CH2. That means I'm only touching these two carbon. Okay, so these three carbon, okay, remain the same together with their hydrogens. Now, there will be double bond between these two carbon now. This will be H, H, then here H. Now, any cis-trans isomerism shown by this alkene, okay, we check the carbon sharing the double bond. This carbon bonded to 2H, okay, not different groups of atoms, no cis-trans. So this is our third alkene. So elimination of B will give us three alkenes, 1, 2, and 3. But we are looking for two alkenes only, right? So B, I think B is not our answer. Let's check C. Right. Let me erase all this now. We look at C. Okay. Now the structure of C, yeah? C, C, H, okay, Cl, bonded to CH3. This carbon bonded to H and bonded to two CH3 group, two methyl groups, yeah? So the same thing, it will undergo elimination. We will remove Cl and then one hydrogen from the adjacent carbon. Right, I think I better show display formula on this side also. Right, okay, I would like to change the position of this so that it's easier for you to look at it. I put Cl here. It doesn't matter, yeah, I put Cl here or here because they are still bonded to the same carbon. Alright, now same thing, this carbon has two adjacent carbon atoms which have hydrogen bonded to them. So the same thing, I'm going to use two different color to show the two different elimination. One is I remove this Cl and one H from the left hand side adjacent carbon. It will give me this product CH3. Okay, Now there's a double bond between these two carbon because each of them will remove one atom. This is CH3. Then this carbon is bonded to H and CH3. Now let's check if the carbons are bonded to two different groups of atoms or not. Okay, now this C bonded to two CH3 group, no cis trans isomers, so only one alkene. Okay, let's look at the other elimination. If I remove this Cl, and then I remove one carbon from the right hand side carbon, one hydrogen from the right hand side carbon. So now I'll get double bond between these two carbon. Right hand side carbon now bonded to 2H. Left hand side carbon bonded to H. Also bonded to this whole group of LQ. Okay. Now because this C is bonded to two hydrogen, there is no cis trans isomerism. So again, only one alkene here. So this is the second alkene that we can get. So the elimination of C molecule will only give us two alkenes. Just now 3, right, for B. Now 2 for C. So the question say, when heated with sodium hydroxide and ethanol, a mixture of only two alkenes is formed. So the answer is C.